Hey, in this video I'm going to talk about algorithms in C++, so some simple searching and sorting algorithms. These are usually taught in introductory C++ courses in high school and university, so if you're in that situation and you're learning these specific things, then this video will probably be useful to get an intro into these and kind of understand how they work. So first, let's look at searching an array. So you can do a linear search really simply by just looping through all of the elements in the array linearly from the start to the end. This is good if the array is not sorted and you just need to go through and find a specific element. So I'll just use this as an example and I'll explain how it works. So here we'll test the linear search and I'll explain this and we'll go through it together. So to begin, let's look at the linear search function. It takes in an integer array and also the size and the key. The key is the integer we're looking for inside the array. And here we loop through from integer I is equal to 0 until it's less than or equal to size. And then we increment I. And if it's equal to the key, we'll just return I, which is the index. Otherwise, we'll return -1, which is the way we signify that there's no key found. All right, so here we have this array. It's got just 1 to 9. The size of it is size of R divided by... So this is basically the amount of bytes inside of the array, that the amount of bytes that the array takes up. And this is the amount of bytes that a single element of the array takes up. So if you divide the total by the size of 1, it'll give you how many elements are in it. So in this case, there's 9 elements. The key is 5, so we're looking at 5. So this should return 0, 1, 2, 3, 4. So we should get index of 4. And if we run this, it'll say key found at index 4. So this runs as expected, like we just said. And now if an array is sorted, there is a faster way of doing this. So we can use an algorithm called binary search. You've probably heard of this, which basically does it in O of log n time complexity, whereas this is O of n time complexity because it has to loop through the whole array, whereas this halves it each time, so it's O of log n. And we'll test it out here and I'll explain how it works. All right, so if we look at binary search, first we have a low value and a high value. So the low value, and these are inclusive. So the low value is 0 because the answer could be at index 0, and the high value is at size -1 because the key could be in index size -1. And now we just loop through while low is less than high. So basically you can think of low as a pointer at the start, high as a pointer at the end, and we kind of just narrow it down as we go through. And if they both point at the same thing, that means we've narrowed it down to one character, and if this character is same as the key, then we'll return that index, otherwise we'll return -1. So here, calculate the mid, which is just low plus high divided by 2. Now there's one thing that I'd like to change here. Sometimes you can get an integer overflow if you calculate it this way, and what a lot of people like to do is write low plus high minus low divided by 2. So this does the exact same thing, except you don't add two integers together before you divide, and so it will reduce, it won't give you an integer overflow if you give like a really long array. And now here we just check if the value at the midpoint is equal to key, we'll return key, and otherwise we'll either move the high to mid -1, or we'll move the low to mid +1. And so if we just run this code, we can see that 5 found at index 4, so this also works with the same array. All right, now let's look at selection sort and insertion sort, and then we'll look at an introduction to recursion. So selection sort is a simple algorithm that takes an array and it's got the sorted and unsorted part and repeatedly selects the smallest element from the unsorted part and moves it to the left. So I'll just paste this in and we'll test it out. All right, so here we have this array, it's not sorted, as you can see, 64, 25, 12, 22, 11. We just get the size of it like we did earlier, and then we run a selection sort on it. So this should sort the numbers, and then we loop through each element in the array, printing out the element. So now if we run this code, you'd expect it to print out, the fully sorted array, 11, 12, 22, 25, 64. So now let's look at how it works. So it takes in an array and a size, and now it loops through from the integer 0 up to size -1. So this doesn't include the very last number, because if you've sorted the whole array and there's one number left in the unsorted area, then it will just take that number and slot it in. So basically here, we'll take we'll have a min index. So this is going to be the min value of the unsorted array. And so, wait, what I said earlier, if there's one number left, then it has to be in the sorted spot, because it's taken every number that's smaller than it. So the last number must be the largest number in the array. So you don't need to loop through. This would also work, I believe, if you just wrote this, but you can just skip that last number. And now here we'll find the smallest integer in the unsorted part of the array, which is, the unsorted part is from I up to size -1 in those indexes. So here we'll loop through I plus 1 up to less than size. And the reason we don't look at I is because we initially set it to I, so we don't need to look at that again. And we just check if this new number is smaller than our current min index, we'll set the min index to j. And then we'll swap the current element with the smallest one. So in the first iteration, it'll be pointing to the first number. It'll loop through the whole array, find the smallest one, and then put it back into the first. So if we look at this example, first I is pointing to this. We loop through the array, it sees 11, and it swaps 11 and 64. And then it'll come to the next spot, and it'll loop through the array. It'll see 12 is the next smallest number, because this will be set to 64. So it'll swap these, and it'll be 11, 12, and so on. So that's how selection sort works. Now let's take a look at insertion sort. So this compares one item at a time to each new element to those already sorted. So I'll paste it in and then I'll explain how it works. All right, so we have this array here that's unsorted, 12, 11, 13, 5, 6. And when we run it, it gives us the sorted array, 5, 6, 11, 12, 13. And not going to go over this because you've already seen it, but insertion sort, basically to make this simpler, I will just print the array at every step after each iteration. This needs to be a new variable like j. All right, so here you can see the first thing it does is it swaps the 11 and the 12. And then it stops. So then the next step that it does is it moves the 5 all the way down to the left. And the next thing it does is it moves the 6 all the way down. So basically at each step, it looks at the integer at I, and it moves it as left as it can possibly push it, basically. So here, the 11 can't be moved to the left at all. Or initially, it's like this. So the 11 can be pushed over 1, and that's what it does. And then you've got this array. So then it looks at the 12. The 12 can't be moved to the left because it's already larger than this item. The 13 also can't be moved to the left because it's larger than this item. But then for the 5, it's able to move it all the way down to here, since it's smaller than all of these items. And then the 6, it also just moves down until it is in the right position. So let's look at how it actually does it with the code. So it loops through from I is equal to 1 to I is less than size. Now the reason it does this is because you don't need to look at the initial character and see if you can move it to the left, because this obviously can't be moved to the left. There's no space there. So it starts from this element, the second element, at index 1, and it will basically, while the index is less than 0, so you don't go out of bounds, and also the number in this new integer is less than the key, and the key is the current integer we're on, it will just move it to the left, basically. Move the jth item to the right. So in this case, when the 5 is moved to the left, it basically pushes the 13 over to the right and pushes the 5 here. It just swaps them. And then it sees that 5 is smaller than 12, so it swaps it again. And then it sees 5 is smaller than 11, so it swaps it again. So that's basically how this chunk works. And here we just printed the array, so that's not anything. And then at the end, we set this final value equal to the key. So we set this spot to 15. So first we push all of them over to the right, and then set this to the 5. Okay, now let's look at recursive algorithms. So this is how to calculate the factorial of a number. So I pasted the code into here, and we can see that recursive algorithms basically have a base case and then a recursive case, and the recursive case just calls itself. So in the base case of factorial, if n is equal to 1, it will return 1, and otherwise it will return n times n minus 1, or n times factorial of n minus 1. So if you understand how factorial works, this will make a lot of sense to you. And so that's basically how recursive algorithms work. In this simple case, we can see if we run it, we get factorial of 5 is 120, which makes sense. So yeah, that basically wraps up this video. In the next video, I'll look at some classes, so all of this stuff as a peek into that. So yeah, thank you for watching and have a great day.